we're going to review like the trigonometry that you would have done in your geometry class. So just right triangle trigonometry, sine, cosine, tangent inside of right triangles, solving for side lengths, solving for angles, measures, solving for triangles. Just a review. We'll have you, after that, we'll have a delta math to practice that stuff. And it's probably going to kind of finish us up for today. I don't want to get too far ahead. Make sure that we can kind of do this set of skills before we start extending on these, right? Everybody cool with the plan? All right. My stylus. Okay. So as we mentioned last time, we talked about SOHCAHTOA, right? And what this is, it's a definition. It's just like the mnemonic definition, but it says in a right triangle with acute angle theta, sine theta equals opposite over hypotenuse, cosine theta equals adjacent over hypotenuse, and then tangent theta equals opposite over adjacent. So it's an expectation that I would have of you guys that you'd come in and you'd have this kind of memorized as our starting point, hopefully. Again, we felt maybe a little rusty last time we talked, but we're going to do some practice today. I bet it'll come back pretty quick. And that's fine. It's been, 10 weeks since you've probably done any math. Unless you're just a math fan over summer. It's like, I need to do me some trigonometry this summer, but probably not. So let's just look at a couple of examples. So let's say we have a right triangle as drawn here. We're asked to solve for the side length x. So the first thing that I'd want to do is I want to make sure that I at least label in my head. I will write it down on our paper as well here. But what sides are opposite, adjacent, and hypotenuse relative to the angle that's given, so the 37-degree angle. So what is this side here? Opposite, adjacent, or hypotenuse? Hypotenuse. Okay. What is that side? Oops. That side there? Opposite. And then the x then obviously has to be adjacent, right? So looking at our three choices, the sides we care about are the 10 and the x, right? Those are the only two sides we know about or want to know about. Those are sides are opposite and adjacent. So which one of the three trig functions do we need to select? Tangent. Very good. So we'll say that tangent of angle 37 is equal to opposite over adjacent. Any questions so far on how we've set up this first equation? Is this looking familiar? Feel familiar? Good. Okay. I want to start with something we feel good about before we, move on to new things, right? Let's make sure we have a nice foundation. So to solve this equation for x, what should I do first to solve this equation for x? Anyone feel brave and want to venture a guess? You don't have, if you're not right, it's okay, right? This is part of like thinking aloud. I'm definitely I want to think it aloud, talk it through kind of person. I think that really helps me. That's what we're trying to do here. So there's no embarrassment, no penalty for giving a wrong response or not knowing exactly what to do. Just take a risk. Edie.
Is it inverse tangent or no?
So we don't need to use an inverse tangent unless the variable we're trying to solve for is inside the trig function. So here our variable is outside, so we don't need to use an inverse. Really, all we want to do is get the x by itself, right? So algebraically, what do we need to do to get that x by itself? Okay, so we can divide by 10. So I'll write that. Now, what is left on the right-hand side after we divide by 10? Not x. Right? What we've really done here.
Oh, 1 over.
Yeah, 1 over x. Yeah, you're multiplying both sides by 1/10. That's the same thing as division. So we can do right that way. 1 over x. That's an important distinction, though. That's a very common mistake to miss, that we're still in a fraction here. Does everybody kind of see what happened? Okay. Now what do you want to do? Have we got the x all by itself? Not really, because it's still in the denominator of that fraction, right? How do we get it out of the denominator? So you could multiply both sides by x. Now, as an option here, I would have rather done that as my first step than doing what we're doing now, because we're going to end up having to move the 10 again, which we already did once. But we'll write that down over here, and then we'll come back to this other one that we've started and just show you how you would finish that one off if you had chosen to kind of go that route. Right? So if you took a different first step and multiplied both sides by x, that's what my first step would have been. But let's go back to here and see how we recover this, or the best way to recover this. Here's what we'll do. If we could just flip the 1 over x would be good, right? You can flip both sides of an equation. That's fine, as long as you're doing that same thing to both sides, that's okay. So you could do that, and that's x by itself. Or if we went this route where we multiplied both sides by x, which I think is the cleaner way of doing it, we can then just divide by the tan 37, and notice we're at the same spot, right? If you have your graphing calculator with you, please take it out, and let's do 10 divided by tan 37. So when I did 10 divided by tan 37, I get 13.27-ish. Who got something different than that when they typed in their calculator? Show of hands. Okay, great. You typed it in exactly like I did, though, right? Your calculator gave you a different number. What happened? What's that? Hold on. Emmy, what did you say? Not in the right mode. Yes, that is correct. What mode does our calculator need to be in? Degree. So to change the mode of your calculator, you press the mode button right next to the second button. And then that third option is radian or degree. Make sure you have degree highlighted. In this course, we will move back and forth between degree and radian mode. So we're going to have to be careful with our calculator, make sure that when we're doing our work, we're in the proper mode. We'll talk more about radians later. If you didn't talk about that in your geometry class, which some of us might not have gotten to, we'll talk about what a radian is and how we use it to measure an angle also, but that's a couple sections down the road. Or if you just don't remember, like what the heck a radian is, that's okay too. We're going to do it again. Don't fear. Today, we're going to just live in degree land. So we got about 13.27. If you switch your mode and redo that calculation on your calculator, you'll now get the 13.27. Does everybody feel okay so far? No big deal? Look familiar? All right. Let's do another. Okay, so we have this right triangle. We start by, again, we want to identify the sides that are opposite adjacent hypotenuse. Again, you can do this in your head if you're doing a problem. I'm going to write them down on our paper just so everybody's clear and sees it again for reinforcement. What side is this one that the x is? Opposite. Very good. And then this side over here, hypotenuse, very good. And then the third side would be adjacent. Okay. Now the two sides we know about are opposite and hypotenuse. So the trig function we'll choose is sine. So what do we write? Sine of 18 degrees, good, equals x over 7. And now when I'm writing these, I'd like to get in the habit of writing the degree symbol, especially in this class where we'll be doing things in radians and things in degrees. I'm going to try to be really careful about writing that degree symbol for myself, so halfway through a problem, I don't get confused as to whether I'm in radians or degrees. Just letting you know that I'm going to try to always do that, and I'm doing it for a reason. If you don't do that, it's not wrong, but I'm telling you my reasoning for doing it, and it's probably a good idea to try to start. Just throwing it out there. Okay, so we have our equation, sine 18 equals x over 7. To solve this equation for x, multiply both sides by 7. Good. And that's like it, right? It's calculator time now. If you have a calculator with you, I invite you to type this in along with me. Make sure that you're getting the same numbers. So I got 2.16. So far, so good? Okay. Question so far? Still feel good? It's coming back. Okay. Actually, I'm going to put the 8 there. All right. What do you notice that's different about this problem than the previous ones? Nicole. Okay, well, we'll say it's x degrees. But I think what you're saying is that the variable is a angle measure as opposed to a side length, right? Everybody notice that the variable is in the angle rather than on a side? Right away, what is that going to tell me? I'm going to need to use an inverse, right? Either sine inverse, cosine inverse, tan inverse. We'll have to use that along the way. Is everybody cool with that? Okay. So those are nice things to notice right away. So if you get lost in the midst of the problem, you know at least like, hey, there's going to be an inverse in here. That helps, right? All right. Same setup as before. We're going to start by identifying which sides are opposite, adjacent, hypotenuse. Starting at the top. What's that top one? Very good. And then the 3 is? Great. And the 8 is? Your geometry teacher did a very good job of schooling you on the opposite, adjacent, hypotenuse thing. All right. In this case, we have adjacent and hypotenuse, so we need to write cosine. So we'll say cosine of x equals 3 over 8. So far, so good. And as we identified earlier, we do need to use an inverse because my variable is located inside of my trig function. In order to cancel out the cosine to get the x by itself, I need to use cosine inverse, right? So we'll do that to both sides. And those guys like cancel each other out. And we're ready to go, right? It's calculator time now. We got our answer. So that's 6798. Feeling good? Okay. Yes, sure. Okay, so the directions here I've changed. Instead of just being solve for x, here we're asking the exact value for x. When we ask for an exact value in mathematics, what are we saying? What does that really mean? What should our answer look like? Yeah, Josh. Okay, like a whole number, specifically no decimal. So it might include a radical, it might include a fraction, could have a pi in it, but it's not a decimal, right? We want no decimal, no rounding. It's an exact value. Is everybody okay there? Now, how do I do that if I have to use sine, cosine, or tangent? Because that's just, a decimal is going to come out of my calculator on that. What am I going to do with that? Yeah, so I'd have to round there, but the directions are specifically telling me not to. Oh no. Well, if you recall, there are two special right triangles. You had the 45, 45, 90 triangle. And the 30, 60, 90 triangle. Does that look familiar? These two will come up quite a bit here as we build out some of our trigonometry tools. So it's a good review here. If I look at the triangle in example A here, what kind of triangle do I have? Yeah, that's a 30, 60, 90, right? If I have 30 and 90, the other side must be, or the other angle must be 60. So I know that the ratios for that 30, 60, 90 triangle have to be the same. So opposite the 30-degree angle, that's the A side. Next to the 30-degree angle, that's the A root 3 side. And the hypotenuse is the 2A side. Is everybody okay there? Now I see from my drawing that, that A is 3. And I know if X is 2A, well, that's just going to be 2 times 3, or 6, and I'm done. That feel okay with what I did there? So again, if you're asked for an exact answer, you're going to be using one of these 30, 60, 90, or 45, 45, 90 triangles. And you're not going to be using sine, cosine, tangent. If there's no indication that you must provide an exact answer, calculator rounding, totally fine. Okay? Only if it asks for an exact answer would you have to break this out. Everybody feel good? Let's do one more. Right? Make myself a little bit more space. Oops. Okay. What type of triangle do we have? That's the 45, 45, 90. Okay. So I know in the 45, 45, 90, the legs are A, and the hypotenuse is A root 2. So we know that A root 2 is equal to 10. Now I need to get the A by itself because I know A is also equal to X. So if I can just solve for A here, I have my answer, right? So what do I need to do to get A by itself? I would not square both sides. That'll give me an A squared over there. And in fact, we're going to kind of be making things worse if we go that route, right? What operation is going on between that A and the square root 2? Multiplication. So if I want to get the A by itself, I need to divide by square root 2. Does everybody feel okay there? Okay. I know the square root looks kind of scary in there, but it's okay. Now we have A equals 10 over square root 2. Is that how we'd like to leave that answer? Probably not, right? What do we like to, what's wrong with this answer? Why don't we like it? Well, it is exact, right? Like there's no rounding happened in there. But there's something visually about this answer that we probably don't like. The square root is in the denominator, right? If you remember back to geometry, typically we didn't like to leave our answers that way. What did we call the process where you try to get the square root out of a denominator? Do you remember what that's called? It's called rationalizing the denominator. That rings a bell, maybe, maybe not. Does anybody remember how to rationalize a denominator? Edie?
Don't you just multiply the top and bottom by square root 2?
That'll do it. Yeah, absolutely. Now it gets a little bit more complicated if there's like a sum or difference in the denominator, but if it's just like one thing. So 10 times square root of 2 is just 10 root 2. What's root 2 times root 2? Not 1.
2.
Regular 2. Or you could think about it as the square root of 4, which reduces to 2. Yeah. Does that feel okay? Now look at that fraction. Is there anything we can do with that? Simplify. What can we simplify, Nicole?
The 10.
With?
Yeah.
She's saying this, right? The 10 over 2 can reduce. So this final answer can be 5 root 2. What do you think? Does this feel relatively familiar? All things I think you've done in your geometry course. I know that was 2 years ago. And you'll see where the algebra 2 pieces come in here later. But right now we're just starting. This is kind of our starting point. Questions so far? How do we, yeah, Josh?
How do you get the cosine negative in your calculator?
Yeah, so to type in the cosine inverse, I press the blue second button, and then I press the cosine button, and that'll give you the cosine inverse. So like if you look at the cosine button above it in blue has cosine inverse, any of those blue commands you access by pressing second and then that button. And then any greens, if you see the green ones on there, you press alpha and that button will get you the green command. Okay? Very good. I think this feels like a decent stopping point here. I'm going to give you guys some time to work now to practice on this stuff that we've just reviewed. So our practice is going to be on the delta math. Let's see. So it's already there. I have a trig review from geometry assignment. Oops. And let me just kind of, oops, that's not what I wanted. I just want to kind of walk through what the question types are going to look like. Okay. So the first one is a timed question where it's asking you to just, it's giving you the 3 sides. It's asking you like which one is sine A. So A is here, opposite over hypotenuse should be 40 over 58. I pick that. And then it's going to keep track. I need to get 10 of them inside of 100 seconds. So if you fail to do that or you get one wrong, it just resets and you just can do it as many times as you want. You just have to complete it. Well, you get 10 of them correct inside of 100 seconds. So it's going to just make you do it over and over again. You'll have 5 questions where you have to find the missing side using trigonometry. Again, if you get one wrong, that's not a problem. It's just going to make you keep doing until you get 5 total. There's no penalty for wrongs. You don't have to start over and get 5 in a row, just 5 total. Everybody's okay there? Just like we did in examples, right? And then your last one, we're going to be solving for an angle inside a triangle. Again, same story. You have to get 5 correct total. Doesn't matter if you get them wrong. It's just going to make you keep doing them and doing them and doing them until you get 5 total. There's no penalties for wrongs. You're going to have to get 5 in a row. And that's it. So you have like, whatever, 10 questions plus that timed thing where it's kind of like 10 questions that are also, but they're like 10-second questions or something, right? You guys feel good on what you have to do? Now, if I'm you, I probably have a sheet of paper out because the ones where I have to solve for X, I probably want to write some stuff down before I type my answer in. Notice that on these questions where it's asking you to round to the 10th, what decimal point is the 10th? It's 1 decimal point. So round to the first decimal point. Okay, make sure you're paying attention. I think they probably all will say the 10th, but make sure you're reading the direction. If it changes, adjust your answer accordingly. It's a bummer when you're like, oh, I did this all right, and I got it wrong because I typed in I rounded to the wrong place. Or it's like, oh, really?